We're going to do several examples so that you can see the types of factoring that we will use to factor polynomials completely. This first one is a third degree or a cubic polynomial because it has a 3 here. And the first thing I want to ask myself is there a greatest common factor that I can pull out of this? So I notice that I have a 20 here, and so the first thing I'd want to do is see if 20 will divide evenly into 220 and 600. It does, so I will use that as part of my greatest common factor. I also see that I have x's in every term, and the smallest exponent, remember that's what's going to determine our greatest common factor, is a 1. So I need to divide everything by 20x to simplify this a little bit. I don't want to be doing an x puzzle with numbers like 600 and 220. So let's go ahead and pull out that 20x. So remember that comes out to the front, and then we want to say what we have left and put that in parentheses. So I'm going to say that I have an x squared and a minus 11x and a plus 30. And that's what I have left when I divide everything by 20x. And now I'm ready to fill in an x puzzle because I notice that this has 3 terms, 1, 2, 3. If you need to look at this graphic, this flowchart that I've given to you, and notice that after we factor out a greatest common factor, we count the terms that are left. If we have 3, we're going to use quadratic form. So that means that we will be using Xbox method. I want to say A times C in the top, and my A value is the 1 in front of x squared, B is negative 11, C is 30. So A times C, 1 times 30, will be 30. And then B is negative 11. So I want to find factors of 30 that multiply to be 30 but add to be negative 11. So 2 negatives is what I'm going to need for this because they have to add to be negative but multiply to be positive. So I'm going to start with negative 1 and negative 30. Negative 2, negative 15, negative 3, negative 10, negative 5, negative 6. And the ones that will add to be negative 11, well, that's going to be the negative 5 and negative 6. So those are the factors that I put in to solve my X puzzle. And remember that those are also going to go over here in my box, my next step. So in the spots in my box here, a 5x and a negative 6x. Both of those are negatives. And then I need to put my x squared and 30 in the other boxes. So x squared here and 30 from our original, well, not original, but our polynomial after we pulled out the greatest common factor. All right, so now I just need to figure out what the greatest common factor is along each row and then each column. So looking along this row, I have an x that they have in common. So I'm going to write an x here. Along this row, I see a negative 6 and a 30. They have a negative 6 in common. Remember that whatever the sign is on the term right next to where you're about to write is the sign that you need to use. So I'm going to say negative 6. Down, I have an x, and down I have a negative 5. So these are my factors, x minus 6 and x minus 5. I have 20x. After that, I'm going to put my parentheses that I learned from my x box, x minus 6 and x minus 5. Now, what we need to do next is ask ourselves, are we finished factoring? There are 3 times when we are finished factoring. The first is if we have a monomial term. Remember, mono means 1. So if we have a single term by itself as a factor, we can't do anything else with that. So the 20x is done. The next time that we are done factoring is if we have linear factors. Linear meaning that it has an exponent of 1. Remember, that's a linear polynomial. And so these both have exponents of 1, and so we are done factoring. The other time when we will be done factoring is if we have an exponent that's greater than 1, but it's just simply not factorable. We try to look at the factoring methods and none of them will work. Before we move to the next problem, I want to just make a couple of notes here. I want to remind ourselves that we used greatest common factor first, and then after that we used our X box. That way when you go back to look at these notes later, you'll remember exactly what we did.